Right, welcome to another edition of Final Countdown. This is week 9, day 2. Let's get into work. Right. Consider the following statements made about the logic gate shown. Now these are AND gate. These are AND gate. When P is 1, so whatever you put for Q, if you put 0 here, it becomes 0. If you put 1 here, it becomes 1. Right? No? So this is correct. No? Next one. Next one. So here, if Q is 0, whatever you put here, this is going to be 0. This statement is wrong. Next one, when P is 0, guaranteed R is also 0. So A and C both are correct. Answer is answer number 3. A and C both are correct. Answer is answer number 3. Right. Moving on. A ball B is projected horizontally with the velocity u, and a ball A is dropped vertically from rest. Which of the following statements is true? So whatever happens, initial vertical velocity is 0. So time taken to reach down vertical will be the same. So both A and B reach the ground at the same time with the same speed. Here wrong. Same time is correct. A and B reach the same ground, but B has a higher speed than A, correct. But when B comes down, there will be a horizontal velocity as well as a vertical velocity. A is coming down, only the vertical velocity is there. So this will have a bigger velocity. Correct statement is answer number 5. Correct statement is answer number 5. Right. Moving on. MCQ 3. MCQ 3. As shown in the figure, a ball of mass 6 kg released from rest at point A on a smooth track ABCD slips without rolling. The ball climbs up vertically to a height 3 meters along the rough surface. The energy lost due to friction. So let's find the energy A, gravitational potential energy, 6 G into height, 240 joules. Here, energy at C, 6 G into height, 180 joules. So what can you say about the energy loss? 240 minus 180, 60 joules. Answer is answer number 4. Answer is answer number 4. Right. Moving on. Two uniform discs A and B shown in the figure are made from the same material. These two are made from the same material and have equal masses. The radius of the disc A is greater. This radius is larger than this radius. The discs are kept in isolation. Consider the following statements. Disc A takes a longer time than B to gain a given speed under an external force. So both are having the same mass. If I apply the same force, they will get the same acceleration. So longer time is wrong. Statement A is wrong. B. Disc B takes a longer time than A to gain a given angular speed under an external torque. So torque is equal to I alpha. Same mass, larger radius. Moment of inertia of A is greater than moment of inertia of B. So angular acceleration of A is smaller than angular acceleration of B. By same torque, large inertia means small acceleration. So B takes a longer time than A. That is wrong. That is wrong. This beat has higher rotational inertia about the axis than this K. Who has the bigger moment of inertia? A has the bigger moment of inertia. C is also wrong. All A, B, C are false. All A, B, C are false. All A, B, C are false. Right. Figure A and B show when a painter is painting. Now here there are two tensions balancing the weight 400 Newton. 400 Newton. Here there is a single tension balancing a weight 400 Newton. So here two tension balances 400. Tension is equal to 200 Newton. Here T2 is equal to 400 Newton. So if the rope is light, then the tension of the ropes are A rope 200, B rope 400. Correct answer is answer number 3. Correct answer number 3. Right. Moving on. A trolley is moving with a constant velocity V. Three men A, B, C are pulling three strings in such a way that their tensions T1, T2, T3 are respectively shown. When the trolley is at a distance L, work done. Now remember, all these three people are inside. Now if you are inside the vehicle and you pull inside, the full system, these tensions will cancel off. If you take the full system, these tension cancels off. If you take a full system, these tension cancels off. So the work done will be 0. So work done will be 0 because they are all internal forces. Right there. All forces are internal. All forces are internal. Therefore, if we consider the full system, all the forces will cancel off. All the forces will cancel off. Right. Question number 7. A toy in the form of a child figure holding a section of a thin ring, which causes two identical heavy metal balls, is made from a thin metal sheet as shown in the figure. So you are balancing this in stable equilibrium. Stable equilibrium means center of gravity is below the pivot point. Now this is the pivot point, so center of gravity should be below the pivot point. Most suitable location is T. Right there. In stable equilibrium, the center of gravity should be below the pivot point. The center of gravity should be below the pivot point. The center of gravity should be below the pivot point. Therefore, most suitable location is T. Most suitable location is T. Right. Look at this. Starting from rest, a sphere takes time to roll on a rough inclined plane. If the plane is made frictionless, time taken by the sphere to slip down will be. Now sphere is rolling means there is linear kinetic energy and rotational kinetic energy both. And guaranteed there is going to be static friction here. Now if there is no friction, this is going to slide down. This is going to slide down. Slide down means only linear acceleration is there. Right. So if you look at this carefully, what will happen? So compared to these two, which will have the bigger acceleration? This will have the bigger acceleration. Smooth surface will have the bigger acceleration. Right? Bigger acceleration means lower time. Lower time. Right there. When the object is rolling without slipping, when the object is rolling without slipping, when the object is rolling without slipping, there is two kinetic energies. There is two kinetic energies. There is two kinetic energies. Rotational kinetic energy as well as translational kinetic energy. Rotational kinetic energy as well as translational kinetic energy. Rotational kinetic energy as well as translational kinetic energy. But when it's sliding down, there is only translational kinetic energy. But when it's sliding down, there is only translational kinetic energy. There is only translational kinetic energy. Therefore, it will have a bigger acceleration. Therefore, it will have a bigger acceleration. Right. Question 9. An organ pipe is filled with oxygen. Pipe is filled with helium, same temperature. The new fundamental pressure. So, look at this carefully. V is equal to gamma RT over molar mass. Gamma RT over molar mass. Organ pipe with its open or close. NV over 4L. So frequency is proportional to velocity. Velocity is proportional to 1 over molar mass square root. Look at this carefully. Now oxygen has a larger molar mass, so smaller frequency. Hydrogen has a smaller molar mass. Right. So fundamental frequency F naught 1 over 32. 1 over 32 square. Oxygen. Fundamental frequency hydrogen 2. Divide the second equation by the first. F naught dash over F naught. 16 square root is 4. F naught dash is 4 F naught. 4 F naught is answer number 5. 4 F naught is answer number 5. Question number 10. Rays from a monochromatic source of light are deviated by an optical element as shown in the figure. This type of optical element is, you can see the top rays are coming down, bottom rays are going up. Bottom rays are going up. So either it can be two prisms kept like this. This is also okay. So convex lens is also okay. Okay. Convex lens also seems like to be a very good option. Right? A single prism. A single prism. But a single prism also works well. So if you look at this, look at this. So if you take a prism, light rays can come down, rarer denser towards, denser rarer away. So yes, so combination of two prisms like earlier one, that's a good option. So if you look at this, so convex lens is a good option. Rays from top come to the bottom, rays from bottom go to the top. Okay. So if I look at this in detail, so I drew it earlier also here. If I keep a prism like this, guaranteed again. So combination of two prisms. So prism and convex, you put both together. Combination of two prisms. Right. Figure shows the wavefronts emitted by three sound sources. These figures respectively represent the sources. What are the sources? Here, you can see moving towards the left, moving towards the right. This is velocity of sound equals velocity of source. So moving to the left or right, moving to the left or moving to the right with the speed of sound. Correct answer is answer number 5. 11th one, answer number 5. Right. Question number 12. A student vibrated a tuning fork and listened to its sound while keeping it in air. Then he vibrated this tuning fork again with the same amplitude and listen to the sound while holding his hand against a large wooden board. So large wooden board, what happens? The vibration energy is transferred to the board, but the molecules here are not free to move. Molecules here are not free to move. Molecules here are not free to move means quickly energy will be lost. But if you vibrate this in air, vibration occurs, transfer, air molecules will vibrate for a longer time. So time during which the tuning force, when it's kept in air, they are on the board. Correct one is 5, right there. If we keep the tuning fork on the board, if we keep the tuning fork on the board, if we keep the tuning fork on the board, the wooden molecules are not free to vibrate. The wooden molecules are not free to vibrate. So it will take a longer time to vibrate. So it will lose energy quickly. So it will lose energy quickly. So it will lose energy quickly than in air. Right. A tuning fork is at resonance. Tuning fork is at resonance with a sonometer wire. Consider the following stage. The standing wave is set up in the wire. Correct. Resonance means same frequency, large amplitude vibrations. If the tension of the wires increase, resonance length will decrease. So here they are resonating with the same frequency. F equal 1 over 2L square root T over M. So if the tension in the wire is increased, F will tend to increase. To keep this constant, L should increase. So statement B is wrong. Statement B is wrong. Amplitude of vibration should be maximum if resonates at the fundamental mode. Fundamental mode only there is largest amount of energy. So correct, A and C correct answer is answer number 3, right there. At the fundamental mode, the greatest vibrating energy occurs. The greatest vibrating energy occurs. The greatest vibrating energy occurs. Which of the following statement is true for mixture of ideal gas at a given temperature? All the gas molecules in the mixture have the same speed. Molecules of each component of the gas have same average kinetic energy. Light gases have low average, heavy have higher average. Root mean square velocities are the same. Wrong. Molecules of each gas component have the same average kinetic energy. Average kinetic energy directly proportional to the absolute temperature. We can't say the velocities are same. Velocities will be different. Okay. And also because different gases are there, different molar masses are there, root mean square velocities are different. But the average kinetic energy is always the same. Average kinetic energy is always the same. Right. Look at this question. Volume V1 of air at 100% humidity, that means saturation occurs, is mixed with V2 completely dry air at the same temperature and pressure. So the final volume becomes V1 plus V2. What's the relative humidity of the mixture? Look at the board here. So RH is 100%. RH is 100%. That means absolute humidity divided by absolute humidity at saturation multiplied by 100. So this value is fixed. 100% here. So absolute humidity is equal to absolute humidity at saturation into 100. So absolute humidity equals absolute humidity at saturation. So mass of water vapor per volume is saturated mass of water vapor per volume. M equals Ms. So the mass of water vapor is equal to saturation. Right. Now what do? I add additional volume. Now same mass of water vapor is there. Don't forget. Same mass of water vapor is there. Same mass of water vapor is there. But the volume has increased. Dry air is mixed. Dry air is mixed. dry air at the same temperature and pressure is mixed. Final volume becomes V1 plus V2. Right. So mass of water vapor there is M. Here equals M. Now I add V2 volume, which has dry air. Here, which has dry air. So mass here, mass of water vapor plus the mass of dry air divided by total volume divided by absolute humidity and saturation. Saturation depends on the temperature into 100. Saturation depends on your temperature into 100. Right. So what will you write here? Look at the board. Here Ms plus mass of dry air, total volume V1 plus V2, Ms divided by V1 into 100. Be careful. Okay. Now what? You have mass of saturated vapor. This mass of saturated vapor density is mass of volume. Right. So you are adding the volume. Final volume has increased. That this volume consists of vapor density V2. So initially it's saturated. Mass of water vapor is equal to saturated mass. So let me draw this a bit. Mass of saturated vapor. So simple logic. What have I done? I have added more volume. That means I have added more mass. Same temperature. That means saturation vapor pressure does not change. Temperature does not change. But more volume is there. Right. Look at this carefully. So here volume is V1, RH is 100%. Saturated vapor mass is there. Now I am adding more volume V1 plus V2 at the same temperature. Saturated masses also there plus. Now mass is added, dry mass is added, M dash. Temperature remains the same. Here. Now here what you have to realize is I keep on adding mass or volume is added, but the temperature remains the same. Temperature remains the same. Right. Now Right. So volume V1 saturation mass is Ms. Unit volume Ms over V1. For a volume V1 or V2, what's the saturation mass? Ms over V1, V1 plus V2. So much of mass is needed to saturate. To saturate. So what we can do is, now we can find the relative humidity. We can find the relative humidity. The mass of water vapor that is already there. Mass of water vapor that is already there. Now if you look at this, they are telling the volume V1 RH 100%, volume V2 completely dry air, unsaturated vapor is added. The new relative humidity is, so V1 volume had 100% RH, V2 volume also has dry air is added, saturated mass and dry air both are now added. Here, both are added. Volume is V1 plus V2. Right. So to saturate the vapor required is so much. RH is the mass added. The mass added here. Already saturation mass is there. Additional V2 is added. Dry mass is also added. Now we are asking the relative humidity. Here. Dry means unsaturated vapor. Unsaturated vapor. Now here saturation already has taken place. So here dynamic equilibrium is taking place. So whatever is added only, already it's here. Whatever is added only will change the humidity. So added mass is M dash divided by saturated vapor mass. So if you look at this, Ms over V1, V1 plus V2. Already saturation occurs here, it's already occurred. So the mass of water vapor it can keep. The mass of water vapor it can keep is going to be Ms. Saturation has already taken place. Ms into 100. Ms cancel off. V1 divided by V1 plus V2 into 100. That is your RH. Again look here, already saturation has taken place. If I add more volume, for this volume saturated vapor mass is found. Now what has happened is, even though I add this, already saturation has occurred. So maximum mass of water vapor there is Ms cancel off. Simplify. This is your new RH value. New RH value. So V1 divided by V1 plus V2 100%. Answer is answer number 3. Answer is answer number 3. Here. Answer is answer number 3. MCQ 60. Consider a situation where a layer of ice is being formed on Arctic sea water due to a constant temperature difference between seawater and atmosphere. The variation of the rate at which the heat is transferred from a unit area of ice is best represented by. So how do you think the rate in which heat transfer occurs? Well, very simple. The rate in which heat transfer occurs, ice layer is formed. Q dot is equal to K times A delta theta over L. Now thickness increases, rate will reduce. Correct answer is answer 1. Correct answer is answer 1. Question number 6. Question number 6. A particle with charge q mass m travels perpendicular to uniform magnetic field in radius r. So here there is a magnetic field. Charge enters with a velocity v. That means left hand rule, field, current, force. So it will travel in a circular path. Who is providing centripetal force? Magnetic force will provide the required centripetal force. M omega squared r. Omega is 2 pi f whole thing squared r. BQB. Look at this curve. So here it's rotating with a frequency. So you can rewrite the relationship. So if you rewrite the relationship, V is equal to R omega. R omega. Here we will write in terms of omega. One omega cancel off, one radius cancel off. Omega equals BQ over M. Omega is 2 pi F. BQ over M. So what can you say about the magnetic flux density? 2 pi frequency M divided by Q. 2 pi frequency M divided by Q. This is your answer, answer number 2. Answer number 2. Right. Read this carefully. When the value of R2 in the figure is varied from 0 to infinity. 0 to infinity. Yeah? The variation of the voltage V is, so this is, let's say, 0. 0 means here there is no voltage drop. Here there is no voltage drop. That means this voltage is divided here and here. There is a voltage given. So voltage here will be less than V0. V is less than V0. So V can't be 0. This is removed. This is removed. This is removed. It can be between this and that. So when R2 is 0, V is going to be less than V0. Right. Now when R2 is infinity, when R2 is infinity, is current going to travel in this branch? No current. No current means no voltage. No current here means no voltage here. So no current in this circuit. No current in this circuit. Think carefully. So there is no current traveling here. No current there. So this voltage 0. So the complete voltage will be here. So what's happening here again? Look, if this is infinity, no current there. No current there means no current here. Here voltage is 0, complete voltage will be there. V is equal to V0. V equal V0 means correct answer is answer number 1. Correct answer is answer number 1. Easy work. Okay. Right. Moving on, very simple. If the current passing through the network shown is I and I2 respectively, I2 divided by I1 is equal to, look at the board carefully. Here the potential here same. Potential here same. So these two can be joined together actually. Then these two are parallel. These two also can be joined together. RR. So here you have R over 2, R over 2, R over 2. R over 2, R over 2, R over 2. So what's the current I1? So I1 is equal to voltage V divided by 3R divided by 2. 2V divided by 3R. What about here? If you look at this carefully, non-resistant wire, potential here, same. Potential here, same. So if you are drawing this, how will you draw it? Here, dividing. Here, dividing. Potential here. Now, potential there is a resistance. So these two I can join together. Here, from behind there is a resistor there, join together. Then this joint and that joint, this joint, that joint, all four resistors are parallel to each other. Why? This and that connected. This and that connected. This and that connected. So opposite potentials connected. Here R over 2, R over 4, R over 2. Half, 1. 1 and quarter, 1 and quarter. So here current is I2. Voltage divided by 5R divided by 4 is I2. That is 4V divided by 5R. 4V divided by 5R. So what is I2 divided by I1? 4V divided by 5R divided by 2V divided by 3R. Simplify 2 times 3 over 5. 6 over 5. 6 over 5 means answer number 4. 6 over 5 means answer number 4. 6 over 5 means answer number 4. So if you look at it carefully, you can get the answers. Right, answer is there. Next one. MCQ 20. Cells E1, E2 shown in the figure have zero internal resistance. Voltage across the terminals are. So guaranteed there will be a current passing through. Please apply Kirchhoff. Sum of EMF equals sum of potential differences. Minus to plus, plus to minus. Current into double the resistance. So E1 minus E2 divided by 2R, that's going to be the current passing through. So actually what's the voltage here? Voltage here is terminal potential difference. So current is going out means E1 minus I times R. That's your terminal potential difference. So what is the current? E1 minus E2 divided by 2R times R. So simplify the R. 2E1 minus E1 plus E2 divided by 2, that's going to be V. E1 plus E2 divided by 2, that's going to be V. Terminal potential difference. So your correct answer there is answer number 5. So the basic experience. Apply Kirchhoff, current will go across the two terminals. So terminal potential difference will be there. Terminal potential difference is the voltage. Okay? Right. Moving on. Look at this carefully. You are asked to design and perform an experiment. Design and perform an experiment to determine the specific heat capacitor metal using metal mixtures. Water, thermal insulated calorimeter, stir, thermometer, small metal blocks and 100 are given. What other instruments you need to measure? So we need triple beam balance. We need a triple beam balance. Triple beam balance. Thermally insulated calorimeter, thermometer, small metal blocks are all given. Stir is also given. Thermometer is also given. So guaranteed we need a triple beam balance to measure mass. What is the advantage of using thermally insulated calorimeters? So what's the advantage? No heat loss to the surroundings. No heat loss to the surroundings. So we can specifically say no heat loss due to conduction. No heat loss due to conduction. No heat loss due to convection. And no heat loss due to radiation. No heat loss due to radiation. Also we can say no heat loss due to evaporation. Evaporation is another method in which heat can be lost. Evaporation is another method in which heat can be lost. Right. List the measurements you would obtain in the experiment. Mass of empty calorimeter and stirrer. Mass of empty calorimeter and stirrer. So the mass is M1. Mass of calorimeter, stirrer and water, that is going to be N2. Initial temperature. Initial temperature of water. Initial temperature of water. Final maximum temperature of mixture. Final maximum temperature of mixture. Final maximum temperature of mixture. So like this you must write with me here. Next one. Mass, final mass of the calorimeter with all its contents. With all its contents. With all its contents. Right. The amount of water used in the calorimeter should not be too small or too large. Give a reason if it's not too small. Too small, metal balls will not properly mix. Will not properly mix. Sudden evaporation will take place. Evaporation will occur, causing loss. Causing loss of heat. Causing loss of heat. Right. Give reasons as to why it should not be too large. Large amount of water it will take a long time to absorb heat. And the increase in temperature will be small. Increase in temperature will be small. So if it's taking a long time, increase in temperature is small. There. Increase in temperature is small. We can write some more. Also, large amount of water when stirring, water might splash out. Water might splash out. Right. Suppose the following values are calculated in your experiment. Heat gained by calorimeter stir at 24. Mass of metal balls decrease in temperature. Right. Heat given equals heat absorbed. Heat given 2400. Sorry. Heat absorbed by the water is 2400. Right. Heat given is mass of metal, specific heat of calorimeter into change in temperature 64. 2400 divided by 0.3 into 64. 0.3 into 64. Your answer is 125 joules per kilogram per Kelvin or Celsius. We can write one more point here. What is it? When transferring metal, water might splash out. So large amount of water, it will take long amount of time to absorb heat. The increase in temperature will be small. Point form. Large amount of water, when stirring, water will splash out. Also when transferring metal, water will splash out. Why is it not suitable to heat the metal balls in water bath at 100 degrees in order to obtain the metal balls heated at 100 required for this experiment? So why aren't you putting this in a water bath and heating? Now when you transfer the metal balls, what will happen? You will transfer with water. When we transfer the metal balls, we will be transferring with water. Into the calorie meter. Right. Instead of using small metal balls, it is possible to use metal powder. Answer is no. No, powder will not mix with water. Large surface area, loss of heat due to convection. Where? Loss of heat due to convection. Okay. Right. Essay question of these. Figure shows a cross section of an eye. Although it is normally considered as the eye lens is responsible for the formation of the image, actually it's a combination of the cornea and the eye lens that forms the image. The cornea can be considered as a convex lens with a fixed focal length, while the focal length of the eye lens can be adjusted according to muscle movements. Right? Assume that the cornea and the eye lens can be considered as a composite lens consisting of two thin lenses in contact. The distance from the composite lens to the retina is 2 centimeters. Calculate the power in diopters when it's at the far point. So light rays coming from infinity will converge on the retina. 1 OV minus 1 OU equal 1 OF. Here distance is 2 centimeter. Focal length is minus 2 centimeter. Power is equal to then plus 50 diopter. Plus 50 diopter. Okay. Next is if you keep it at the near point. If the object is kept at the near point, 25 centimeter, light rays coming from here will converge on the retina. 2 centimeters. 1 OB minus 1 OU equal 1 OF. Object is at 25. Image is formed at minus 2. Focal length 1 OF. Simplify this carefully. Here 50 here, minus 25, minus 2, 1 over, minus 50 over 27. Power is equal to minus 1 over 50 over, convert to meter, plus 2700 over 50. 5, 4, 54 diopter. So one is 50 diopter, the other is 54 diopter. 54 diopter. Is the image real or virtual? It's real. Invert. Real inverted image. The power of the cornea is 40 diopter. Calculate the power of the eyelids in both the cases mentioned. Effective power is given, power of the cornea, power of the eye. Effective power here, first case 50 diopter, cornea is 40, power of the eye, that is plus 10 diopter. Second situation, power of the cornea plus power of the eye, 54 here, 40 diopter, power of the eye. Power of the eye is equal to 14 diopter there. So 10 diopter, plus 10 diopter and plus 14 diopter is found. Plus 10, plus 14. Plus 10, plus 14. Right. You can see they are simple work. Consider two tiny dots, small separation d on paper. Obtain an expression for the distance s between the two images formed on the retina. So if I draw the ray here, this distance SI can find. Let me take this as theta, easier. Tan theta is equal to opposite d over 2 over adjacent. Tan theta opposite s over 2 over adjacent 2. So d over 25 equals s over 2. They are asking s in terms of d. 2 over 25 d. 2 over 25 d. S equals 0.08 d. S equals 0.08 d. Right. Easily found. Next is what? Letters and images printed by some computer printers consist of many closely placed dots as shown in the figure. For this happens, the separation of images on the retina by any two adjacent dots must be less than the value S max calculated. If the value of S max is 8 micrometers, so they are telling enlarge letters T, not visible to the normal eye. For this happen, separation of the images must be less than a certain value S max. Right. If the value of S max is 8 micrometers, show that the dot separation of 0.08 is sufficient for the letter to be seen without dots. Right. So S is equal to 0.08 D. So maximum S 8 micrometer, 0.08 D. Simplify this. 8 10 to the power minus 6, 8 10 to the power minus 2. Answer is 10 to the power minus 4. So here it's going to be 0.1 millimeters. So maximum dot separation possible is 0.1 millimeters. So 0.08 millimeters is less than 0.1 millimeter. 0.08 millimeters. This is less than that. Therefore, dots cannot be seen. Cannot be seen. So if the separation is more than this, dots can be seen. So this value is less than that. So dots cannot be seen. Okay? So very simple theory. S max is given, get the dot separation. Maximum separation which can be not seen. Point. If the separation is 0.08, it's less than this, so anyway it can't be seen. Right. It is necessary to see the dots. I want to see the dots with 0.08 separation. So S is equal to 0.08 D. 0.08 means dot separation also 0.08. That is going to be 64 10 to the power minus 4 meters. That's 0.64 micrometers. 0.64 micrometers, right? First, tell me, can 0.64 micrometers be seen? Can't. 8 micrometers only can be seen. 0.64 can't be seen. 8 micrometers. 8 micrometers. Here 64. So sorry. We want right. (6,400) micrometers left. It is necessary to see the dot separation. It is necessary to see the dot separation. When the separation is 0.08 millimeters. I'm sorry. So here millimeters. Right. What is the maximum focal length of the magnifying glass that should be used? Right. So again, reminding theory. If the separation is more than this, I can see the dots. If the separation is less than this, I can't see the dots. Now when the separation is 0.08 millimeters, here you go the separation. Yes, on the retina. I want to see the dots here. So I want to see the dots means I want to make the image size bigger. I want to make the image size minimum 8. So what's the magnification? So magnification means I want the image to be 8 micrometers. Object is 64 10 to the power minus 4 millimeters. Here simplify this. 1/8. 10 here. 1.25 magnification required. 1.25 magnification required. So if 1.25 magnification required, maximum focal length is at the near point. 1.25. Near point is 25 centimeters focal length. 0.25 is 25 over focal length. F is equal to 25 divided by 0.25. 100 centimeters. So what can you say about the focal length? 100 centimeters. Again look at. So this is the object. Image I want to get it magnified. Minimum this condition 8 micrometer. So magnification is 1.25. So magnification 1.25 means I can find the focal length 100 centimeters. Okay. So now I can see only 64 10 to the power minus 4 with the lens. I should minimum see 8 micrometers. Then only I can see the separation. Okay. Right. Okay then. This concludes week 9 day 2. Catch you tomorrow with week 9 day 3.